All right, so in our class, we've been learning about composite shapes. Composite shapes are composed of multiple shapes that are combined together. So far, we've been focusing more on squares and rectangles. Before we can continue on with this, we have to understand the properties of squares and rectangles. In our class, we talked about squares being similar to rectangles, and we call the sides of a square S. Now, in our class, we've also been talking about a rectangle. How they're different is that we have widths and lengths, length always being the longer part of a rectangle. For a square, if you want to call them widths and lengths, you can. However, they must recognize that all sides of a square are the same, and the lengths and widths of a rectangle are different. That's it. So an example of a composite shape would be a shape such that you have a square and a rectangle combined. Oftentimes, they will not see the line that's in between, so it looks something like this. Okay, so that's what students are practicing right now in our class. Today, we're going to focus on adding the composite shapes. So one of our examples I'm going to pull from our homework today. This will be from homework exercise number 4. And let's take a look at 2B. I'm going to use 2B as our example just because I think they mislabeled it. But the picture looks like this. And I'm not going to draw it exactly to scale, which is fine. It says this is 5 meters. This over here is 10 meters. And it says all the way to the top is 10 meters. That's actually incorrect. Obviously, because on this side, we can see it's greater than 10, right? So that was a mistake from the book. It should go from here to here. We have the length from here to here as 10 meters. Again, 5 meters and another 10 meters. The assignment is asking the students to find the perimeter of the shape, and I'm also asking them to find the area. So I'm going to share with you first off that a perimeter for students, we talked about perimeter, is the distance around a 2D shape. What that means for the students is that students must realize we're going to be going around the outside of the shape. We don't really care about what's on the inside of the shape. And then when they find the area is the space inside a 2D shape. So that's this part in here, okay, that we'll be looking at here in just a bit. Well, we broke this up into a few steps. The first step I told students to do is find all the missing links. So find all the missing links. Once they do that, they can easily find where, what the perimeter and everything else is. So today, as we're looking at the missing lengths, let's go ahead. I don't know if I can find a pointer here. Does that work? Nope, that's my finger. Okay. Well, here's what we have to remember is that opposite sides of squares and rectangles will be equal. So recognize we are missing this length here, this one over here, up here, to the left of this shape, the bottom of it, and everything else is given. So when we see this, we have to identify what are the missing sides or lengths. Well, they give us this 10 down here, so we're going to go ahead and go all the way up. And notice in this shape here, we have kind of a rectangle, right? So with that, what I will do then is I know that the missing length above it must also be 10. Okay. Same thing here. We have the 5 down here. If we draw this line down, we know the top up here must also be 5. And the last part here, this must be 10. Okay. If we take a look on the left side over here, all the way down, we know the total is 15. Therefore, this part is going to be that 15 minus our known, which is 10. So that's going to equal, I'm going to put here, 5 meters. Now, as we can see, we've gone all the way around the shape. We can easily find the perimeter. So I'm going to start by putting a dot here and say this is my starting point. So perimeter is equal to, we're going to go all around the shape. First, notice that's 10. Oops, I'm missing this question here, but that is given us there, right? So now we're going to go up. That's plus 10. Go to the right, plus 5. Go down, plus 5. Go to the right, plus 10. Go down, plus 10. Go to the left, all the way to the left, we have 10 plus 5 plus 10. That's a total of 25. Oops, I lost that 10. And go back up, that's 5. And notice now we've gone all the way around the shape. We've gone from where we started, went all the way around to where we end. Now it's just a matter of adding up the values. So I always like to add my 10s first. So 10 plus 10, 20, another 10, that's 30, 40, 50, 60, 70, and the 2 5s make 80. So perimeter is 80 meters. That's my answer. All right, so now I have to find the area. Area, we learned in our class, there are 3 steps for area. First step is formula. Second step is substitute. And the third step is solve, okay, and simplify. I'm going to show you how I've been teaching the students with ours. I would note down that there are 3 shapes. I'm going to call this A, B, and C. Notice what the shapes are. So we can find the area by using the formula. Formula is length times width. And step 2 is substitute. We want to look at our first shape A. Let's find the area for A. Okay, our lengths we can see here is 10. And our width is the shorter side is 5. We can solve the area for A, that's 50 meters squared, because it's meters times meters. Same thing for B. This time the length is going to be a little bit longer. We're going to go all the way down, and that's 15. So area for B is length times width. Area for B, substitute, 15. And our width here is 5. And students who are not as familiar with multiplying bigger numbers, they'll need to practice this skill, okay? But 15 and another 15, that makes 30. So we got 60 and 75. So that's 75 meters squared. Okay. And finally for C, the area for C, we can find length times width, area for C. Length this time is going down, that's 10. And going across, I know it doesn't look like a square, but most things aren't drawn to scale. So that's what I've always been teaching our students. So 10 times 10, that's 100 meters squared. Okay. Close now, we have to find, it says the total area. So we have to find the area of all 3. So we're going to say the total area now is equal to the 50 plus the 75 plus the 100. So total area, we can call it T if we need. That's going to be, well, 50 and 70, that makes 125. And plus 100, so 225. And this is, again, meters squared. Okay. So that's what we're expecting the students to be able to do. Separate and recognize the area of the shapes and go around the shapes.